Welcome to Around Space. I'm Kent Miller. Today we'll be talking about the robust, reusable rocket revolution. As you know, for the last half century, we've been working with these metal expendable rockets, which are so expensive and accident-prone that they have limited our ability to develop space. What's new is that DARPA has become interested in this problem. I'm delighted to have with us Dr. A.J. Kothari. He's a rocket scientist. He had his bachelor in physics from University of Bombay. Then he came to America, got his master's and PhD in aerospace engineering at the University of Maryland. In 1982, he became assistant research professor at the university. And then in 88, he founded Astrox. That's a company which does design R&D contracts for the Air Force, NASA, and DARPA. Welcome back to this table.
Kent, thank you very much for inviting me again, and delighted to be here.
All right. Tell us about your 4 R's.
Well, something really wonderful kind of and exciting is happening now in this country and, hopefully around the world also. What it is it's a new revolution. It's a robust, reusable rocket revolution. The 4R, as I named it, just like 4H.
Right. Now, what are the benefits of reusability?
Well, the reusability is absolutely necessary if we really want to become either a spacefaring nation, or we want to go to, Mars and explore, go to the moon, etc. We have to have really, much cheaper access to space, to orbit, than what we have today. If we don't have that, we are probably never going to be able to expand and become a spacefaring nation, or really be able to go to all these other places that we want to.
All right. So reusability brings an advantage in cost, an advantage in flight rate, and perhaps reduces the accident rate.
That's correct, yeah, especially the cost level, which can be reduced, a fair amount, or quite a bit, by using completely reusable. And some of these new companies have picked up on that, and unfortunately they are doing and developing all that. So if I may, let me just sort of start by how this came about, and how my opinions or interaction with this came about. Okay. As such. About 8-9 years ago, the Air Force chief scientist at that time asked us, Astrox, to look at 8 different options, all 2-stage to orbit TSTO options. 6 of them were reusable and 2 were not reusable. One was completely expendable. The other one was called hybrid, which is one stage is reusable, the upper stage, and the upper stage is expendable. So we looked at all these, kind of options, and then they asked us also to look at the cost for access to space along with that. So we did that too. And to my surprise or delight, or whatever you call it, I found that it's really possible to reduce the cost of access to space considerably, from what we have with the ELVs and the Atlas and all that, of something of the order of $8,000 a pound to LEO to, $400 a pound. So it's a huge benefit.
More than a factor of 10.
Yeah, a factor of 20 almost.
Yeah.
So, but then I sort of looked into why it is that that's happening, and in all cases, it seemed to me like the acquisition cost of the vehicles that is taking you to orbit was far overwhelming the cost for, say, fuel.
Sure.
Or other incidentals and other things.
Fuel costs almost nothing
Costs
compared to the
almost
rocket.
nothing. Right, yeah.
Yeah.
And so if you can go completely reusable, then, and so then, this $350 or $400 type of a thing, which would also mean that one can actually have a space tourism type of an industry where people are actually not just going up and down like the suborbital, but actually go into orbit and stay in orbit and enjoy it for, several views around the Earth and then come back and land, etc. So it becomes more palatable. And all that can be done for also about the same price as this, the suborbital per person ticket cost is. What, $200,000? You can
So this would be opening up a new market.
It would be opening up.
We could call it the hospitality industry.
Well, yeah, right.
You could have a hotel in space.
You could have a hotel in space.
People could move back and forth less expensively.
Less expensively. So I mean, this was kind of the this was not the reason for doing it, but this was an implication, an impact on something like that also at the same time.
But I think the military's interest is different. They
Yes,
want something more like of an immediate launch ability.
Right, yes.
If a satellite fails, they want to be able to fix it the next day.
That's right, yes. So if there is some problem, internal or external, whatever it could be, that they want to be able to have responsive launch, responsive access to space.
Okay.
So all this, well, that is kind of tertiary to the cost reduction due to reusable, but it'll come with it.
Right.
And then, of course, the military will develop these kinds of things, which, fortunately, they are doing this, and then it'll be transferred over to commercial market also at the same time, which I'll talk about, in a few minutes. Okay. So if I can just show you, for example, the 8 options, just very quickly, the 8 options that we looked at. Here, the first 2 on the left are expendable or hybrid option, and all the others on the right, 6, are reusable options.
Right.
So the second option here from the left is what we are getting into now as a country. And the first one is what we have been doing so far. So after the which I'm calling option 1, after that's done, then we'll, as a country, we'll hopefully move to option 2 here, which is the third one.
Now, the hybrid means it's the first stage which will be reusable.
That's correct.
So it'll fly back or land somehow.
Right.
And the upper stage would be expendable as before.
As before, right, yeah, exactly. So, I mean, okay, so we take one step at a time, which is fine, which is fine. It's easier to do the first stage than to do the second stage.
Well, technically, it's easier to do the first, and it's the larger portion of the cost.
That's correct, yes. So we both ways we kind of win. No?
Yeah, that's right. Yeah.
So that's what, so, in doing all this and then the cost analysis, I kind of discovered then. So I was fairly, obviously excited about it too. And I wrote several papers on this and presented them in the IAA conferences, Space Planes Conference and other conferences, and wrote some op-ed pieces, about singing good songs about reusability, etc.
Okay.
And whether that went anywhere or not, I don't know, but it appears like this constant barrage that came from me helped. Right. To make a case, at least, to some extent.
So awoke us some interest.
Well, well, it may have come from other sources or anything, but certainly, I hope that I did a small part in that. So now, what is happening now? I mean, look at what's happening. This is something that was never happening before, say, 3-4 years ago or something like that. But now, SpaceX is doing reusable. I mean, they are gung-ho on reusable.
Right.
Blue Origin, Bezos is also, Jeff Bezos' company Blue Origin is also doing the same thing. And, they have been successful too, in
Right.
bringing back the first stage and landing it. And I would say that, okay, so SpaceX had several failures in the beginning, but the last two of them have been successful, that landed on barge. Before that, they had something which landed on ground, on Earth. So that was successful too. But they had, failures also where it came and hit the barge and, it was destroyed. But, at least I would say that they have 50% success rate, let's say.
Well, it'll improve over time.
And it'll improve, I hope. Certainly hope. The Blue Origin people have been almost completely successful.
Okay.
But they are not doing as tough a problem as SpaceX. So, the problem is this, that SpaceX has been successful 50%. So that means that if you fly 2 times, one of them was destroyed. One vehicle was destroyed, the first stage, and the second one, you were able to use the same stage for 2 times, right?
Yeah.
My calculation showed that that's not enough. That it has to be of the order of 100 to 200 times that you have to be successful. So that's why I'm adding that word, robust. So robust is necessary. Reusable, if you just reuse 1 time or 2 times or something, it's just not enough.
Right.
So higher success rate and all that kind of a thing is what is also needed for doing this. So what I wanted to do is to just show you, okay, so to do that higher success rate type of a thing is where DARPA comes into the picture.
Okay.
And DARPA is really doing something grand, something very, very good, which probably can really steer the country and the space transportation industry in the right direction.
All right. Now, the name of this project is XS1.
That's correct, yeah. XS1 is the name of the project that the DARPA is, has a program on that, and the first phase, which I will talk about also, was done, and it's going into phase 2 now, and it's really...
Now, they have a unique requirement. They want to be able to launch 10 times in 10 days.
That's correct, yeah.
So that's airline. That's like an airline.
That's like almost like an airline.
Yeah.
So it's going to be very, very interesting. So, but before going into the XS1, I wanted to just show you what are the differences between what SpaceX is doing and what Blue Origin is doing and what XS1 will do.
Okay.
And what are the commonalities between all that also. So this slide here, the next slide, talks about what SpaceX is, what SpaceX is doing and how they're doing it.
All right.
So SpaceX is basically it obviously takes off vertically. This is the Falcon 9,
Right.
Falcon 9 rocket that they have, which is being reused. First stage.
Right.
That's the first stage. Of course, that second stage
Now-
is also expendable.
Right, but
point in time.
what's unique is that they're actually going to try to land on its tail,
That's correct.
on a barge.
On a barge. They have.
okay.
They have. Right. Yeah. So here you can see in this picture here that it takes off from on the left here.
Cape Canaveral.
It takes off from Cape Canaveral or somewhere, and then it goes to where it can stage the upper stage, which is approximately Mach 6 or 7 or something like that.
Right.
It's gone a little far away from the Cape Canaveral area. Then it lofts the second stage, but then the first stage, which is almost at a gamma or flight path angle of close to 0 or a few degrees,
Yeah.
will turn this way, 90 degrees or 135 degrees, and then it'll start the rockets again
Right.
on
To
the
slow
bottom,
down.
the tail, to slow down, and then it'll come back and land. And by that time, it is landing on a barge. So they were not successful first couple of times,
Well, it needs legs, right?
but at least needs
Just
legs.
the barge might be moving because it's on the water.
Oh, the barge is very well stabilized.
Okay.
That's a special thing. Otherwise, you cannot land there at all, right? I cannot land there.
Yeah.
But It has legs like this, like in this picture.
Right, they fold out.
It folds out,
All right.
and then you can see on the right-hand side where it is just landing on that barge. Last two of their attempts have been successful for landing on barge.
All right.
So, we
So
hope
what's
that,
Blue Origin's approach?
all right, so now Blue Origin. So this slide here shows, okay, now Blue Origin, the difference here is that the SpaceX is doing something where the second stage is actually going to orbit, GEO or LEO or something like that. But Blue Origin is actually just simply going to go up and then come back down.
Okay, vertically.
Vertically. And
Okay.
so it's much easier thing for them to do than what the SpaceX is doing.
Well, they're in a different market. They're the suborbital
They are in
market.
suborbital market, right?
Yeah.
Yes, right. Yeah. So now, that's why I think that what DARPA is doing in terms of Access-1 and all that is very exciting,
Right.
and very interesting. And so let me just talk a little bit about that. So that, and also they have at least two of their options are going to land horizontally, and so that would also help in bringing the robustness to the
Yes.
whole idea, because we have been landing horizontally the airplanes millions of times a day.
Yes, that's right.
And successfully, well, almost all of them successfully. Whereas vertical landing has been, less than that.
Yeah.
So, but basically the thing is that what they are doing is, at least what SpaceX is doing, is they are doing it because they want to land on Mars, on Moon, where there is no air or very little atmosphere on
course,
Mars.
right.
And so you have to have the ability to land
On your tail.
on your tail.
Yeah.
So they are developing that. It's a great thing. But if you are on Earth, and we know that there is air on Earth, right?
Yeah.
So
Okay.
use it is what that means.
Yeah.
Use it and make the thing robust. So that's what Access-1 is doing.
All right, good.
So, so the Access-1 program is a DARPA program which aircraft like Space Access for 21st Century, and Jess Parnable is the program manager for this program. And by the way, I must say that whatever it is that I discuss about Access-1 is my own, and I'm not speaking on behalf of,
Okay, of course.
DARPA or anybody
That's right.
else.
The disclaimer here.
But the disclaimer, it has to be a disclaimer there.
Right. Now, what's interesting is that, I suppose to save money, they've aimed at the light sat market. So these are lightweight payloads.
That's right, lightweight payloads, right, yeah, exactly.
So under 900 pounds?
Well, up to 3,000 pounds.
Up to 3,000.
Up to 3,000
Okay.
pounds, right, yeah.
Okay.
So this, whatever I'm presenting here has been released for public consumption, so
Sure.
it's okay to discuss that.
Now, you mentioned phase 1 is done, right?
Phase 1 is done, yes, exactly. Phase 1 is done, phase 1 of Access-1 is done, and phase 2 is, was announced, and the RFP is going to go out very soon.
Okay.
And then people will send in the proposals. And then, but the phase 1 was awarded to 3 major contractors, Boeing and Northrop Grumman and
Yes.
Masson
Right,
Aerospace, and they had their own people who were subs to them. Now, the phase 2 is not going to be awarded to necessarily one of those 3, actually.
Oh, really?
Even though they were. Phase 2 has been opened up completely
Oh,
again.
my goodness. All right.
So other people, the reason for that is that in last 2 years since this thing started, many other companies like SpaceX and all that have been doing a lot of work on that. So here are the 3 designs of Boeing and Northrop Grumman and Maston. Maston lands vertically, and then Boeing and Northrop land horizontally.
Okay.
And there are also going to be possibilities of aircraft like CONAPs, and of it will go 10 times in 10 days. Does not mean that all 10 of them will go to orbit. 9 of them will not, or 10 of them. The last one has to go to orbit, but the others will just simply take off and come back and land, go to Mach 3, Mach 6, come back and take off and land.
Okay.
Take off and land. And they are going to be like what is called boost back or a glide back type of an option.
Right.
So, but I mean, the whole thing is going to be that XS1 is taken to a clean pad and erected, filled, and just ready to take off. That type of thing.
So we're simplifying the ground equipment.
Simplifying the ground equipment is quite
Yeah.
necessary, actually.
So the vehicle is much more self-sufficient and has its own
that's
electrical power and
Right.
Right.
Yes, right. Yeah, it has all
much
that.
much like an airplane
Much
does.
like an airplane.
Yeah.
And here in this slide, you can see here this three, the new players in this, the SpaceX, Virgin Galactic, and Blue Origin, that they are doing their own things that I talked about earlier. And the XS1, actually, this is like a government, what is called government reference vehicle on the right-hand side in the bottom.
Okay.
That was something that we created. We helped create that.
Right.
That design, Astrox.
All right. Good.
And so, and then there is going to be this, like what you said, this it'll be possible for the XS1 to take small payloads, and now there is this big demand and interest in small satellites.
Right. We have these constellations of large numbers of satellites in low Earth orbit,
Right.
and we need to be able to replace them.
Yeah,
And they're in different orbital inclinations. Right?
That's correct. Yeah, that's
So you
correct.
can't replace all of them with one big launch.
Right, yeah, you cannot, right. Yeah. And now what has happened is that the satellites, because of these technology that we have, that I have in my phone, or your phone, cell phone, that technology has advanced so much that it's possible to make satellites which are 4-inch by 4-inch by 4-inch.
Oh, wow.
And have
Little cubes.
little cubes, those are called CubeSats also,
Yeah, yeah.
and have fair amount of ability to take pictures and do other things and stuff. So it's possible to have to do that, and XS1 can help to do that also at the same time. And not only that, but I think once you have the XS1 done, you can do many other things with it. I mean, these are various different roads that one can take, avenues that one can
Well, you
take,
can
and that's
evolve
what's
it
exciting
now.
about it.
You
This
can
will
evolve it.
it, right?
Yep.
Yeah, and evolve it meaning you put two of these XS1 in what is called a bime's fashion, side by side.
Yes.
And put an expandable in the middle. You can make it bigger, and you can have a reusable rocket that way. So if like, for example, if it's Burmese, then both of them will come back and land.
That's right. So the two are effectively acting as a first stage.
Is the first stage, right? Yeah.
And then they can lift a heavier upper stage.
Upper stage that
Yeah.
way, and heavier payload.
Right.
So there is a way forward with that, and it's just quite.
I would point out that making the upper stage reusable is a little more of a challenge.
Yes, it is.
With the lower stage, you can use low temperature composites because the
Yes.
thermal protection problem is easier.
Easier, right? Yes.
But with the orbital stage, you have to go to high temperature composites.
That's correct. Yeah. So we have to go to height. You have to go to TPS, thermal protection
systems, yeah.
that you have to put on all these things. And you remember the black tiles that the space shuttle had.
Right.
So
Yeah, on the leading edges of the wings.
leading out the wing, and also the entire bottom.
Yeah.
Because you re-enter at like 35, 40 degrees, and it gets very, very hot.
Yeah.
So all of those things, will be needed for the upper stage, and so there are many different ways of doing this. So basically, the XS1, if it can accomplish its goals of 10 flights in 10 days and open a path to on-demand launches and breaks the cycle, it'll be quite a revolution. I think that this whole thing, XS1, SpaceX, and all these is going to really, really revolutionize the space transportation, and we are going to behave differently. We are going to do the space transportation differently. We'll probably be able to build these space stations that we had in 2001: A Space Odyssey. It was 50 years ago, 1968 movie. That Arthur C. Clarke at that time could see all these things. And from there, if you remember, from there they went to the moon, they went to Jupiter, and you know, and all that. So all of these things are things that are necessary.
Right.
And so, but you know, people have not always believed in this. And here is an example of what the New York Times said in 1903, after while Orwell and Wright brothers were trying to do something, that they said that the flying machine which will really fly might be evolved by a combined and continuous efforts of mathematicians and mechanicians. At that time they called them mechanicians.
Sure.
In from 1 million to 10 million years. So,
Yeah.
of course, you know,
It's a rather
this is like
pessimistic
a
view.
Pessimistic view. It is only about 100 years since that time.
Yeah.
And at the same time, the Orwell Wright's diary says on October 9th, 1903, same day,
Yeah.
that we started assembly today. Anyway, I mean, it's not that, you know, that same thing can happen or will happen, but it can happen. It may happen.
Well, I think what's nice is that right now with the Expendables, we're caught in some kind of a trap because our launches per year is the same every year
Right.
with small variation. The
correct.
tonnage we launch to space is the same every year. We're a replacement market. We replace the satellites as they fail. For the foreseeable future, we're stuck. And so
Right.
this looks like a way out.
This is a way out, and this will probably.
Alrighty. Well,
So,
I want to thank you very much for joining us at our table.
thank you, Kat.
That was Dr. A.J. Kotari. He's a rocket scientist. And thank you so much for joining us, and see you next time.
Thank you.